Welcome back. This week we're focusing more on applications of simple interest. So last week was a fairly heavy week for us, really. We covered a lot of topics. We learned about I and S and P, and then we started to put all those together into multiple payments or equations of equivalence and started working with timelines. You may not quite be finished on that material, and that's fine. This week's a little bit lighter in some ways. So if you're still feeling a little bit shaky on some of the material from last week, maybe take the first day this week to review that and finish that up, and then move on into the simple interest applications we're going to talk about today. Simple interest gets used in a variety of ways, particularly shorter term applications. When we have time periods of less than a year, we often see simple interest. Maybe short-term investments like a GIC, or perhaps when somebody lends some money to someone else like an IOU, or more commonly called a promissory note. We also have it for treasury bills, securities that the government issues when it needs to borrow money for short periods of time. Commercial paper is like the equivalent to a treasury bill, but for private companies. And then we've got demand loans as well, where we're going to look at things like lines of credit and that sort of thing, credit card borrowing and whatnot. All good simple interest applications. Now, when we're valuing an investment, typically we want to see what it's worth today, and so we're going to bring back in time all of the future cash flows we're going to get. So that means discounting or finding the present value of those amounts. The interest rate that we're going to use is going to be our desired rate of return, isn't it? So if I want to make 10% on something, I'll discount it or bring it back in time at 10%. So if I want to receive $110 in 1 year from an investment, what would I pay today for that investment if I wanted to earn a 10% rate of return? Well, if I work that out using the P formula, P equals S times 1 plus RT, you see that would be $100, which kind of makes sense, doesn't it? I put $100 in today, I earn 10%, I'll end up with 110 in 1 year. So we can work backwards to find out the price we would pay. The fair market value of an investment is the sum of the present values of the cash flows that we expect. So we may expect a couple of dollar amounts in the future. Well, if we bring them all back to today and then add them up, we can get the fair market value, it's called, of the investment. You may see the terms present value and discounted as well. Present value, discounted value, fair market value, they all tend to mean the same thing, don't they? They're bringing things back in time to today. So if we think about a little timeline, we have some money out here in the future, or maybe some, more than one even. We're going to bring back to today to get the discounted, the present, or the fair market value of that amount of money. Let's have a look at an example. We've got an investment contract that calls for a payment of $1,000 5 months from now, and another payment 10 months from now of $1,500. What price would an investor pay for the contract in order to earn a return of 10%? Well, let's start by putting a little timeline together here for this one. Here we are today. We've got a payment in 5 months and another payment in 10 months that are going to happen. The one in 5 months said was $1,000, and the one in 10 months was $1,500. We want to know what we would pay today. What's the fair market value, or what's the price today? So to do that, I'm going to bring each of these amounts of money back in time. The first one comes back 5 months. The second one comes all the way back 10 months. And I've got a common rate for both. Maybe I'll just write that over on the side here. R is equal to 0.12. So can I figure out the price today? Well, let's have a look. The fair market value, or the price today, will be the first $1,000 brought back at 12% for 5 months. -1 there because I'm going backwards in time, aren't I? Plus $1,500 brought back as well, this time for 10 months. So 10. And again, a -1 there. So let's put those together. If I work those out on my calculator, I get 952.38, and there's more decimals, 1, etc. there, plus 1363.636, etc. And if we add those together, I just showed one extra so that you see when I add them together and round everything to 2 decimal places, I get 2316.02. That's the total that we would pay today in order to collect those 2 payments in the future. And if we did that, we would get an overall return of 12% on our money. Now, often a debt or an investment is going to earn interest until maturity. For example, I might borrow 1,000 today and promise to pay it back in the future with 3% added on top or something like that. Something called a promissory note is very much like that. It's an IOU where we say, look, we're going to repay the original amount plus some interest in the future. Well, in that case, I don't actually know what I'm going to pay in the future, do I? I'm going to have to work that out, and I can use the maturity value formula for that, S equals P times 1 plus RT. That would help me work it out and get the value of what I actually have to pay back in the future. We'd have to do that in every case, wouldn't we? So we knew what to pay back. Sometimes, though, these notes or these contracts are sold before maturity to a third party. And to calculate the selling price, we have to work with that maturity value that we just calculated and then discount that back, often using a new rate. So typically we've got 2 steps for this. First, we'll calculate the maturity using the rate that was originally agreed to in the promissory note or in the IOU. Then we'll discount that maturity amount back to the sale date using the new rate. So if we think of a timeline here, we had an original amount we borrowed. We're going to actually find out what we have to pay back at the end. And then once we've got that, we're going to take it to whatever point it was sold at to work out the selling price. So there's sort of 2 steps involved in this process. Let's have a look at an example. On March the 1st, Murray signed a contract to pay Anton $2,000 plus interest at 8%. And on June 1st, on June 1st, and 3,000 plus interest on September 1st. So there's actually 2 amounts coming back in the future, 2 payments, both with 8%. Then Anton sold the contract. Perhaps he couldn't wait around any longer, or he needed the money or something. He sold the contract to Randy, to a new person, on May the 1st. Randy said, that's fine. I'll take over the right to collect these amounts for you. And I'll give you some money for that today, as long as I make a 10% rate of return. And that's perfectly fine. Randy can have his own rate. There's nothing wrong with that. So we're going to use that one when we do step 2 to work out the selling price. So let's have a look at this question. A good timeline is really nice for these kind of questions. It's really the only good way to get sorted out. So we've got March the 1st here on the go. And Murray signed a contract to pay 2,000 plus interest and 3,000 plus interest. I'm going to put both amounts here. You're going, wait a minute. It was 2,000 in June, wasn't it? Well, yes, it was, but it was 2,000 plus interest, wasn't it? So how do I do plus interest? Well, that's with an arrow. I'm going to have to move it forward. And 3,000 plus interest in September. September 1st. Well, let's just start with this part of it. I think that may be a good way to go. And for this one, I'm going to have to go now to the calculator and work out some days and those sorts of things. Well, the first set of days here is 92 days, and that's at 8%, isn't it? The second line I've got on the go here, if I go to my calculator and work out the days between these 2 dates, I get 184 days at 8%. So let's just start with that. So as our step one, let's work out the June 1st amount. That's $2,000 carried forward at 8% for 92 days. And that works out to be $2,040.33. Well, I also have a September 1st payment that was promised, and that was $3,000 plus interest for 184 days. And that works out to $31.20.99. Now, I can't just add those up because they're on different dates, aren't they? But at least I've got them. Now I can work on step two. Switch to a new color here for step two, just so we can keep it separated a little bit. I want the price on May the 1st using 10%. Well, what's that going to be? Well, let's see. Let's put May the 1st on the timeline here. I want to get the price here. I'm going to have to take the amounts I've just calculated and bring them back, aren't I? And the first one going back from May 1st back to June, or June 1st back to May 1st, I mean, is 31 days. And the second one comes all the way back from September. That's 123 days. And these are both at 10% now, aren't they? We've got a new rate, and that's perfectly fine. Randy doesn't have to agree to the original 8% rate that Murray and Anton had dreamed up way back in March. He can have his own rate. So let's take those amounts back. Well, we know on June 1st there was $2,040 that was supposed to be paid originally. And now Randy's got the right to collect that instead, but he wants to see what it's worth if we use 10%. And we go backwards, in this case, 31 days. Plus, don't forget, Randy's going to collect the second payment as well. That was at 31.20. We'll bring that one back as well. Let's see if I can just squeeze this in here. The 123 days. There we go. A little squishy, but we made it. He's going to get both of those payments. He's going to collect them both. Let's work them out. The first one, once we discount it back, we get 2,023, well, 15 cents, plus 3,019, 25. If we add those together, we get $5,042.39. Now you notice I'm out by a penny. That's just because I rounded, these two when I wrote them down. But in my calculator, I kept all the decimals. So it really did work out to 5,042.39, which is what we want. Let's try one out. I'm going to give you a few minutes to give this one a go. See how you do with it. Leonard borrowed $10,000 from Sheldon and agreed to repay it 6 months later with interest at 8%. After 2 months, though, Sheldon sold the note to Penny at a rate that would give her 6%. Can you calculate the price that Penny paid? So go ahead, press pause, take out a sheet of paper, see if you can work this one through. And when you're ready, press play again, and I'll come back and go through it with you. All right, let's have a look. Let's start with the timeline. Leonard borrowed $10,000 from Sheldon and agreed to pay it back in 6 months with interest. That's always the key phrase we're looking for, with interest at 8%. So we have to watch for that. If it didn't have any interest, well, then we would have put the 10,000 right at the 6 month mark. But there is interest here at 8%, so we care about that. So we're going to carry that forward for 6 months at 8%. And then we come along, and after 2 months, Sheldon sells the note to Penny at a rate that would give her 6%. She might be more than happy with 6, thinking that's a great rate. She doesn't know that it was originally 8 or anything else. So we're going to now bring this back. Now 6 back to 2, that's 4 months, isn't it, at our 6% rate of return. That's going to give us the price that we're interested in. So let's go ahead and try this out. Again, isn't it just the 2 steps? So first we find the original maturity at 6 months, right? And that's going to be equal to 10,000 going forward at 8% for those 6 months. And that works out to be $10,400. Exactly. And then we have to go to step 2 to find out the price that Penny's willing to pay. And don't forget, Penny wants to collect the payment that's due at the 6-month mark. So that's what we're interested in. So we're going to take that 10,400 and we're going to now discount that or bring that back at her rate of 6% for the difference in time of 4 months. And if I put all that in there, and if you put it in correctly too, you'll get $10,196.08. That's the price that Penny would be willing to pay. Now if you say, well, can't I just do a little shortcut here? This seems like too much work. Can't I just take the 10,000 and carry it forward 2 months? Well, we can't because we've got 2 rates on the go. So what would we use, the 8 or the 6? Or some hybrid between the two? Well, there's no really good way to do that. So the far better way, instead of doing that, is to say, look, let's just take it all the way to the end, work out what's going to be paid back, because that's actually what Penny's buying the right to receive. And then we'll discount that back to 2 months and get her payment. I hope that worked out for you. If not, maybe try a couple more from the book, or now that you've seen mine, cover it up, rewind the video a little bit and try it again. Well, that's it for promissory notes or valuation, really. Promissory notes are just sort of the main example, but there's other applications, of course, that work the same way. And so practice some of these. Practice really is important for these because they do take a little bit of work to get the hang of them. And then when you're ready, you'll be able to move on to our next application and our next video all about treasury bills.